since we're familiar with that now. And so from here we can see that our e value is going to be 5/4, which is greater than 1, which means it's a hyperbola. Cool. And then we just need to solve for p, and we need to write down the directrix. So if e is 5/4, then ep, of course, is this numerator, it equals 3. And we just plug in our e value. We get 5/4 times p is 3. We get p being 3 times 4/5, which of course is 12/5. Okay, there you go. That's all of that. And then all we need to finish this all off is to say the directrix would be some x. Let's see. The directrix would be some x equals 12/5. Let's see how we did. Here's the answer for B. Okay, so E is 5/4, X is 12/5. Looking good. And it's a hyperbola. Excellent. There you go. Let's look at C now. All right, last one. R is 7 over 2 minus 2 sine theta. Okay, first time we've seen a negative there. So, of course, we need to change this over. Now we get 7/2 over 1 minus sine theta. Cool. So our E value is going to be... Now, this is complicated because the E value can't be negative, right? But this negative is going to play out at a different role in just a bit. This E value is clearly 1, which means it's a parabola, right? And now, what else can we say about this? We can also say, yeah, this will play out here in just 1 second. We can also say EP equals 7/2. Cool, we know that E is 1, so P has to be 7/2. Cool. That's that. Now because this is negative, let's see how they actually do this, because I just don't want to be thrown off by this. Yeah, so 7/2 over 1 minus sine theta. Since the sine is in the denominator, the directrix, because the sine is in the denominator, the directrix is y equals negative p. All right, great. Comparing that to the standard, e equals 1, therefore we solve this, p is 7/2, excellent. We get a parabola, we saw that, right? We saw that when we got E is 1. And we have the directrix at y equals negative 7. And that comes from this sign right here. So y equals negative 7/2. That's how that plays out. That is all there is to it. All right. Not too bad, hopefully. Here is example 2. Okay, all we're going to do now is take this one step further and actually graph it. So let's play around with this and see how we do. You'll get a lot of practice on this in just a bit. Okay, so exact same thing as last time. We have our R value is 5 over 3 plus 3 cosine theta. All right, we simplify this down. We get 5/3 over 1 plus cosine theta, right? Naturally. We have a plus here, we have the cosine here. This is all good. We find out that our E value again is 1, which means it's a parabola. Excellent. And then our P value is just 5/3. Excellent. And this guy is going to give us our direction. So because this is the cosine, I believe this is x is equal to 5/3. Let's double check all this. Yep, x is equal to 5/3. You can kind of see all the solutions down here. You can see how I did it, how they did it. So we have a parabola on our hands with a directrix. This is our directrix. Good. Here's our p-value. There's our eccentricity. This p stands for parabola. Cool? And we got everything we need. So we just need to graph all this now. So I'll just scan through this so you can look at the book at the same time. But the gist is we know already what? We know this directrix is at 5/3. So let's put that there. This is at x equals 5/3. Right? And we know that the parabola is going to be going away from that directrix. But we can put a few points out there. So let's put a few points. This is basically what they did. You don't need to do as many as they did, but it's easy enough. So you might say to yourself, why couldn't it be going to the right? Totally correct. Let's just put a few things in there. So let's ask ourselves, let's say theta at 0, right? We're going to plug that back into that original equation that we had. So when theta is 0, you can look at the equation here, cosine of 0 would be 1, right? So you'd have some 5 over 3 plus 3, which is 5/6. So I just plugged in this theta into the original formula. And I got 5/6. This r is 5/6. So at 0, we would come out 5/6. So the radius would be 5/6. That is just a little bit inside. That's like there, right? Less than 1, just a touch. Cool? And the theta would be 0. So that's clearly our vertex. And then now all we need is to just figure out, we know it's a parabola, we know it's opening up this way now. Let's figure out basically our y-intercepts. Clearly there's going to be 2 of them, right? I'll just kind of put some dots there. We just need to figure out where they would be. So take a look at this. Clearly this is what? This would be pi over 2, right? And this one down here would be 3 pi over 2. If you're just thinking out loud, that's the 2 thetas we need to plug in. So let's plug in theta equals pi over 2. And we would get r equals what? So again, let's plug it in. So cosine of pi over 2 is what? 0. So we would get 5/3. So that means we go up 5/3, right? And theta is pi over 2. And now to get the other one, we just put in 3 pi over 2, so 3 pi over 2. That means we're going all the way around here. And again, 3 pi over 2 is what? Now this is interesting. So 3 pi over 2, the cosine of 3 pi over 2 is going to be what? So it's going to be -1. So -1 times 3, oh, excuse me, that's pi. That's going to be 5/3 again. Hold on, let's double check this. Oh, it's 0 again. This is exactly right because it's cosine. Okay, right. So this is 0, so we get 5/3, but it's going to be a 5/3 again. Excellent. Now, if it was a sine, right, it would give us a -1, but in this case, it is not. So we get 5/3, so we get this point right here, 5/3, and this point right here, 5/3. Okay, and you should be thinking how we graph these guys out before. So we need a bit of previous knowledge, but it's not too bad. Polar coordinates should never be too intimidating. They never ask too hard of questions on the quizzes either. So there we go. So just to run over how we did that, we used all the previous logic. We just grabbed up some points that were helpful. Notice that I found the undefined bit at pi on accident. Not really necessary though. All right. Next up, graphing hyperbolas in polar form, exact same game. I'm just going to jump straight into it. So r is going to be 8 over 2 minus 3 sine theta. Okay, check this out. We get some 8 divided by 2 is 4 divided by 1 minus 3/2 sine theta. Again, our eccentricity is what? 3/2. So that's greater than 1. So we have a hyperbola on our hands. Great. Our p-value is going to be Let me actually write this out 'cause it's a little more complicated than that. So it's actually going to be 3/2 times p equals 4. So times 2/3 times 2/3. So 8/3 is our p-value. Cool, we got all that going. So we know it's a hyperbola. We know the p-value is 8/3. And remember, this is where things get kind of complicated, but the directrix here, we have a directrix at y equals, and because of that negative in the very beginning, the -3 sine theta, we of course get a y, and it becomes a negative 8/3. All right, easy enough. So our directrix is going to help us, right? That's going to be the first thing we plot, right? So we found our p that